We now solve a problem on LPP formulation. The problem is a manufacturer produces two products A and B. Both products are processed on two different machines. Product A requires 3 hours for both machines. Product B requires 2 hours on machine M1 and 1 hour on machine M2. The available capacity for the first machine is 12 hours and that for the second machine is 6 hours. Each unit of product A is sold at ₹7 profit and that of B at ₹4 profit. Formulate the LPP to maximize profit. So the first step to solve such a problem is to identify the two objects that are being produced. Clearly in the problem, it is clearly mentioned a manufacturer produces two products A and B. So the objects that are being produced are A and B are the two objects that are being produced. So we have to say that let X1 be number of units of A and X2 be number of units of B. This is our first step. That is to identify the two objects that are being produced and calling X1 the number of units of A and X2 as number of units of B. Next, we identify the objective function. Now to identify the objective function, we have to read the last line. Whatever we are going to do, we have to basically maximize the profit. So the objective function will be maximize. If your minimize had to come, it will be minimize. Maximize Z is equal to, now it is each unit of product A is sold at 7 rupees profit. So A is 7 rupees profit. So corresponding to A, rupees 7 is associated. Therefore we write 7. Corresponding to it was X1, so 7 X1. And corresponding to B, it is 4. Therefore we write 4, and with B we add X2, so we write X2. With this we conclude step 2. Step 3 is to form the constraint table. Now constraint table has a pattern. The pattern is name, X1, X2, total. These are the 4 columns. Name, X1, X2, total. Now the name of the constraint, if you read, is everything apart from what is left is what apart from A and B. A manufacturer produces two products A and B. Both products are processed on different machines. Product A requires 3 hours of both machines and product B requires 2 hours of first machine M1 and second machine M2. So our machines M1 and M2 will be our constraint name. So this name is M1, this name is M2. Now X1, if you observe, this is for A. Now over here it is clearly mentioned that product A requires 3 hours on both the machine. So X1 and machine M1 is 3 and X1 with machine M2 is also 3. Similarly, it is mentioned that the product B requires 2 on machine M1 and 1 hour on machine M2. 2 on machine M1. So this is B, X2 is for B. On machine M1 it is 2, machine M1 it is 2, and for machine M2 it requires 1 hour. So this is 1. Now also it is said that the available capacity for the first machine is 12 hours. Now the total is for first machine, that is M1, is 12 and the second machine is 6. So this is also 6. Now we have to formulate the LPP. Now it is said this is the capacity. This is this 12 is the maximum capacity. That means what? If your machine is available for 12 hours, you cannot use it for 13 hours. So maximum use of that machine should be at 12. Similarly, the maximum use of second machine should be 6. Now we will formulate the fourth step. We now move to the fourth step, which is to formulate the LPP. The fourth step is very simple. You have to copy what you got in second step. Copy what you got in second step. Second step says what? Maximize z is equal to 7x1 plus 4x2. 7x1 plus 4x2 subject to, or you can just write such that, such that, then you can write 3x1, 3 is with x1, 3x1 plus 2x2 less than or equal to 12. Now this crocodile sign should face 12 because it is said that 12 is the maximum capacity. So this answer cannot be more than 12. So crocodile should face 12. Similarly, 3x1 plus 1x2 because now it is 1 is less than or equal to 6, and then something you have to write it always true. X1 more than or equal to 0, x2 more than or equal to 0. With this we come to the end of the problem.